हेलो फ्रेंड्स। सो PNB SO इंडस्ट्री ऑफिसर के लिए जो एग्ज़ाम होने वाला है 5th को ऑन मंडे, उसके लिए प्रैक्टिस करेंगे हम लोग थर्मोडायनेमिक्स का क्वेश्चंस। ओके, सो लेट्स स्टार्ट विदाउट वेस्टिंग टाइम। सो लेट्स स्टार्ट। फॉर अदर sections and other chapters, please see my other videos in the same playlist. Okay, so starting thermodynamics. The third level of thermodynamics is all about the third law of thermodynamics. So the third law of thermodynamics deals with entropy of a perfect crystal at absolute zero is zero temperature. Yes, it is right. And the relation between work and heat, it is in first law. Okay, relation between heat and work is in first law. Okay, first law states that all the Q we give to the system will be consumed in either internal energy, raising the internal energy of the system, or system doing some work. So this is the first law. Okay, so this is the relation between work and heat. Evolution of entropy of a system with time. Evolution of entropy of a system with time. Conservation of mass. So conservation of mass, conservation of energy is in first law. Conservation of mass, it deals with the first law, but with steady flow energy. Steady flow energy equation deals with the conservation of mass. Okay, evolution of entropy of a system. Entropy, the concept of entropy is mentioned in second law. Okay, so the question was about third law, so answer will be entropy of a perfect crystalline at absolute zero temperature is zero. Entropy of a perfect crystalline at absolute zero temperature is zero. Okay, is zero at 0 Kelvin. So this is the reference. Coming to the next question. Next question. The ideal gas at pressure P, temperature T undergoes a reversible isothermal compression and attains a pressure P2. Okay. The characteristics gas constant is R. Net heat transfer during the process is ideal gas at pressure P1 and temperature T1 undergoes a reversible isothermal compression. Okay. So work done in net heat transfer during the process. Heat transferred in isothermal process. Okay. So during the isothermal process, we know temperature remains constant and pressure is changing from P1 to P2. So during isothermal process, we know that at every system behaves at every point of the time, system behaves as quasi-static, as if the system is at rest. Like suppose it is a pulley. Okay, it is a piston, and here is a some air, suppose, or gas, and we are dropping sand, droplet of sand, particle of sand we are dropping. Okay, or suppose sand is we are the sand mound of sand is on the piston, and we are removing one sand at a time. So at every point of time, it will appear that the system is equilibrium. So since the system is equilibrium at every point of time, work done is net heat transferred. Okay, so net heat transferred. So work done is zero in isothermal process and a reversible isothermal process, and net heat transferred Q should be equal to E, because W is 0 according to first law. Q equal to E plus W, so W is 0. So Q will be, so a change in energy is equal to ln P2. The logarithmic equation comes. Okay, and the temperature will T1. Temperature will be T1 at every point of time. So T2 is wrong. T1 ln P1 by P2. Okay, it is compression, so P2 is greater than P1. Okay, P2 is greater than P1, so this will be negative term. So in compression the work done will be negative. Okay, so this option will be correct. We all know, suppose if someone has doubt from where this logarithmic term is coming, so we all know work done is minus PdV or d of PV. Okay, so pressure and volume both are changing here, so we can also say it is a minus of PdV. So P is nothing but P equal to nRT by V. Okay, so nRT dV by V. So if we integrate this, it will be nRT or RT1 ln R. Suppose it is for 1 mole, so n will be 1. So RT1, because T1 equal to T2, so we have temperature outside the integration, and dV by V ln V2 by V1. So ln V2 by V1. Okay, if we put the constants, so V2 by V1 is also equal to P1 by P2. So this will be RT1 ln P1 by P2, because in isothermal process P1 B1 equal to P2 V2. So B2 by B1 is equal to P1 by P2. So option 2 will be correct. So coming to next question. So please remember, during isothermal compression or isothermal process, logarithmic term comes in work, in heat or energy, because work is 0. Next question. For system to be in thermodynamic equilibrium, the temperature and the pressure have to be same everywhere. Only temperature have to be same everywhere and the pressure can vary. The temperature and the pressure both can vary from point to point. Only pressure have to be same everywhere and the temperature can vary. So for a system to be in thermodynamic equilibrium, suppose this system is in, we know chemical equilibrium, we know mechanical equilibrium, and we know thermodynamic equilibrium. Thermodynamic equilibrium, temperature and pressure have to be same everywhere. Temperature have to be same everywhere and the pressure can vary. Temperature and pressure have to be same everywhere. So question option 1 will be correct. Okay, suppose this is a system, so if its temperature is increasing, then this is not in thermodynamic equilibrium. In a chemical reaction, temperature increases or decreases. So during a chemical reaction, system is not in thermodynamic equilibrium. Okay, and pressure also changes during a chemical reaction. So option 1 will be correct. Next question. A rigid tank contains the steam at a pressure of 60 bar and a specific enthalpy of this. Which of the following is correct for this steam? Given specific enthalpy of saturated liquid water at this is this, specific enthalpy of frozen water at this is this. Okay, so we have to find correct for this steam. A rigid tank contains the steam at a pressure of 60 bar and has a specific enthalpy of this. Okay, which of the following is correct for this given enthalpy of saturated liquid water at 60 bar. Okay, so enthalpy of steam is equal to enthalpy of saturated liquid water plus x times enthalpy of saturated gas minus saturated liquid. Okay, so 1210 it is given, saturated liquid is 1210 plus x times specific vaporization of water, specific enthalpy of vaporization of water at 60 bar, specific enthalpy of vaporization of water. Okay, so this whole term is given. This is the enthalpy of vaporization of water. Okay, sorry, that is the latent specific enthalpy of vaporization of water, kilojoule per kg. Okay, vaporization of water, specific enthalpy of vaporization of water at 60 bar. Okay, so Hg is given 1575 minus 1210. Okay, so this should be Hs, and Hs is given to be 2470. Okay, this is the specific enthalpy of vaporization of water. So vaporization of water, for vaporization of water we have latent and we have at 60 bar. Specific enthalpy of saturated liquid, it is not saturated gas, it is not saturated water vapor, it is enthalpy of, so this whole term, I think this whole term is given. So let's assume that this is Hg minus HL is given 1575. So 2470 minus 1575 should be equal to, sorry, 2470 minus 1210. 2470 minus 1210. Okay, 2470 minus 1210, it should be 1260. So 1260 upon 1575, so this will be less than 1. Okay, yeah, so this whole term is given 1575 Hg minus HL, vaporization of water. So 1260 upon 1575 should be dryness fraction of this system. So 9, with 9 we can go with 9 1 9, 9 4 36, 9 1 9, 6 9 7 63, 4 9 5 45. Again with 5 we can do 5 2 10, 5 8 40, 5 3 15, 5 7 4 4 by 5, it is 0.8. correct, 0.8 is correct. Steam is superheated. For superheated it should be 1, so this is wrong. Steam is wet with a dryness fraction of 0.2, it is wrong. Steam is dry saturated, no, for dry saturated it should be 1, so only 1 is correct. Okay, so enthalpy of vaporization of water is given at 60 bar. So Hg minus HL, both Hg minus HL, this whole term is given as 1575. Okay, if you anyone have any doubt, kindly comment. Okay, So next question number 4 or 5. A perfect gas at 25 degrees Celsius is heated at constant pressure till its volume. A perfect gas at 25 degrees Celsius is heated at constant pressure till its volume is doubled. The final temperature will be. So pressure is constant. So going by PV equal to nRT. Pressure is constant, so volume is doubled, so temperature should be doubled. So 25 degrees will not be 50 degrees Celsius. It should be 25 plus 273 Kelvin, 298 Kelvin into 2, 596 minus 273 for degree Celsius, 323 degrees Celsius. Okay, first convert into Kelvin, then into 2, then again into for degree Celsius, minus 273. Okay, next question. To determine the quality of wet steam by a separating and throttling calorimeter. Quality of a wet steam, okay, by separating and throttling calorimeter. The steam should be first separated and then throttled such that the final state is for throttling. The final state is the pressure higher than the original pressure at mixture of saturated liquid and vapor, superheated vapor only, saturated vapor only. The steam should be first separated and then throttled such that the final state should be superheated vapor only. Okay, because we have already separated the water from the steam, so it should be superheated vapor. Next, so are we marking, or let's see. We have to mark also. So here option number 1 is correct. Okay. Here, and this was correct. RT1. Next, here temperature and pressure both. Next, steam is wet. Next, 323. Next, superheated vapor. Okay, next, thermodynamic non-flow work is the product of an intensive property with. Thermodynamic non-flow work, okay, is the product of an intensive property with non-flow work. Okay, non-flow work, okay, is the product of an intensive property with. Okay, so non-flow work is PdV. Okay, so volume is extensive, pressure is intensive, because pressure remains constant even if we increase the volume. Suppose this is our system, so in the half side whatever pressure is acting, in the full side if we remove the partition, in the full side same pressure will be acting, so it will not increase, does not depend on the volume of the system. So pressure is intensive. Okay, same pressure P is acting this side, half, in the half of the system or in the full of the system, so same pressure P is acting, so pressure is intensive and volume is of course extensive. Intensive and extensive we can find whether it is depending on the mass of the system or not. So pressure is not depending on the mass, but volume is depending. Okay, more mass then more volume with an extensive property. Other extensive property, change in an extensive property. Yes, dV is the change in extensive property. So option 3 is more appropriate. So let's mark option 3. Next, identify the correct representation of the Mayer's equation. R is Cp minus Cv. Okay, Cp by Cv is gamma. This is gamma, degree of freedom. Gamma is Cp by Cv. Gamma is called sorry, okay, time is up or what? Never mind, let's complete ours. Let's complete first. Gamma is Cp by Cv. Okay, you are given thermodynamics, right? Yeah, well, let's complete it first. Okay, let's see whether we have answered correctly or not, whatever we have done. So we are correct, every question is correct. So in the next section, let's complete all the remaining. Okay, or we can continue the video, no problem. Question number 8, identify the correct representation of the Mayer's equation. Okay, so Cp minus Cv and Cp upon Cv is gamma. Gamma is equal to 1 plus 2 by f. F is the degree of freedom. Okay, degree of freedom. For monoatomic, it is 2, 3 and 5. Monoatomic, diatomic, triatomic. Okay. For monoatomic it is only translational and rotational, so 2. For diatomic it is rotational in both axes, so 2 plus 1 translational, it is 3. Similarly for triatomic it will be 5. Rotational in all 3 axes and translational in both the axes. Okay, so oxygen is diatomic, ozone is triatomic, phosphorus is oxygen is diatomic, triatomic and monatomic. Carbon, nitrogen, these are monatomic. Okay, so degree of freedom is 1, 2, 3, 5 and gamma is 1 plus 2 by f. F is the degree of freedom. Also Cp by Cv is equal to gamma. Cp is the specific heat capacity at constant pressure, Cv is the specific heat capacity at constant volume. Okay, so the here answer will be R equal to Cp minus Cv. Next question. Okay, we are correct. In a cyclic heat engine, source temperature is 800 degrees Celsius and sink temperature is 30 degrees Celsius. Its maximum efficiency will be. So in a cyclic heat engine, okay, so efficiency, maximum efficiency will only be there if the engine will be acting as a Carnot cycle. Okay, so in Carnot cycle efficiency depends on the temperature of sink and source. So it is efficiency is T2 upon T1 minus T2. Okay, so T1 minus T2 is 800 minus 30. The difference will be same in Celsius. So 800 minus 30 is 770, and T2 is 273 plus 30, 303, and 770. Maximum efficiency will be, so approximately we can find out it is suppose 300 upon 770, 30 upon 77, 30 upon 77 will be 30 upon 78 will be 10 by 26. Okay, so let's find out simply 300 upon 70 and 30 upon 7, 300 upon 78. Let's find out this. 78 5 ja, no, it will be 4 ja, it will be 3. Okay, 78 3, so it is 77. Okay, so let's find out 300 upon 77. Okay, so 300 upon 77, so 77 into 4. Let's find out. Okay, and we can also find out 5. 385. So it will not be 5, it will be less than 5, it will be 4 or 3. Okay, 308. If it is 4, so it will be 3. 27 3. It is 300 or 800. It is 800. Sorry. It will be 800. So we have to convert it in. Okay, 800 minus 30 is 770. So 770 upon 273 plus 30 is 303. So let's say suppose it is 300, so 300 upon 770, 77 4 ja, it will be 308. 77 3 ja, so none of the option is matching. Maximum efficiency will be this T2 upon T1 minus T2 or T1 upon T1 minus T2. Okay, source temperature is 800, so 303 upon 770. 77 3 ja 231. 308. So 40, around 40, less than 40, but okay, none of the option matching. Let's see the solution quickly. Okay, difference is okay 1 minus d low by Ti. Okay, efficiency. So it is 1 minus sink upon source. or we can do simply difference upon we were doing earlier T2 upon T2, that is the refrigerator, I think. So for heat engine it is difference upon difference was 770 upon high, 2800 plus 1173 1073, 800 plus 273. Okay, so 1073. It will be difference upon higher. So we can calculate this. Suppose this is 1073. Suppose it is 1100. 11 7 ja 11 10 ja, so 0.70%, but it is more than 70%, so it will be 71.8%, because we have taken 1073 as 1100, so it will be our answer will be little less and actual answer will be little more. So 70% little more, 71.8%. Okay, next question. Let remember this formula, 1 minus T low by T high. Okay, for heat engine. And next it is 9, so let's 10. Okay, reattempt mode. Starting from the same initial conditions, an ideal gas expands from volume V1 to V2 in 3 different ways. The work done by the gas is W1 if the process is purely isothermal, W2 okay. Starting from the same initial conditions, an ideal gas expands from volume V1 to V2 in 3 different ways. The work done by the gas is W1 if the process is purely isothermal, W2 if the process is isobaric, and W3 if purely adiabatic. So we know the graph, it is expansion. So adiabatic, isobaric and isothermal. It is isothermal, suppose temperature it is PV equal to constant. So which graph will be isobaric and which graph will be adiabatic? This is isothermal, so isothermal will be in middle, so W2 will be in middle, so only one option, W2 is in middle. So even if we don't know concept, this particular question can be solved, but let's learn the concept also. So okay, W1 is pure. Okay, isothermal is in W1. Okay, so this is wrong, this will be correct. Isobaric, so constant and adiabatic expansion is the lowest. Okay, suppose PV equal to nRT, we know na. Okay, so temperature is constant, means PV is constant in this line. Okay, so in isobaric pressure is constant, so pressure T1 upon V1 equal to T2 upon V2. Okay, in isobaric T1 upon V1 equal to T2 upon V2. It is PV line. Okay, so pressure is constant, so this will be like this. Okay, so isobaric will have the largest heat. If we draw again, it is P, it is V. In isobaric pressure is constant, so a straight line. In isothermal PV equal to nRT. In expansion temperature will reduce, so this P1 V1 will be more than this P1 V1. In adiabatic it will be even more less. Okay, because in adiabatic PV gamma equal to constant. Okay, so if you want to find whether what will be v2. So v2 p1 v1 की power gamma equal to p2 v2 की power gamma. So v1 upon v2 upon gamma equal to p2 by p1 upon gamma. Okay, so v2 it will be 1 so we know. Okay, it will taking longer time, so let's move to the next question, and answer will be 1. Okay, yeah, this is the graph. Next question. Okay, 10 questions are already done, so let's end this session, and the next session we will do the next 10 questions. Okay, thank you. For other sections, other chapters, please go through the playlist. Okay, thanks so much. Best of luck for your exams.